Welcome to the session on numerical methods, iteration. The objectives for this session are to use iteration to find approximations to the solutions of equations of the form f of x equals 0. We can use an iterative method to find a value of x for which f of x equals 0. To solve an equation of the form f of x equals 0 using an iterative method, rearrange f of x equals 0 in the form x equals g of x, and then use the iterative formula xn plus 1 equals g of xn. Let's take a look at an example. The function f of x equals x squared minus x minus 1 equals 0 can be rearranged as x squared equals x plus 1. We've simply moved minus x minus 1 to the right-hand side. This implies that x equals square root x plus 1. We've simply square rooted both sides of the equation. If we rearrange f of x equals x squared minus x minus 1 equals 0, we can also get x times x minus 1 equals 1. Here we've simply moved the 1 to the right-hand side and then factorized the left-hand side. If we divide the equation by x minus 1 on both sides, we obtain x equals 1 over x minus 1. Or we can rearrange f of x equals 0 to give us x equals x squared minus 1. So we have three iterative formulae. xn plus 1 equals root xn plus 1 from the first equation. Xn plus 1 equals 1 over xn minus 1 from the second equation. And xn plus 1 equals xn squared minus 1 from the third equation. So to summarize, the function f of x equals x squared minus x minus 1 equals 0 produces the three iterative formulae on your screen. Now some iterations converge to a root, and this can happen in two ways. The related diagrams are either the staircase diagram or the cobweb diagram. We also have some iterations which diverge. Let's explore these in the next few slides. Let's take a look at part A first. Remember that one iterative formula produced by f of x equals 0 is xn plus 1 equals root xn plus 1. Here's a sketch of y equals root x plus 1 and the graph of y equals x superimposed upon that. We're going to try and find the point at which the true graphs intersect. Let's start with the point x0 equals 0.5. As shown here, we read up from x0 on the vertical axis to the curve y equals root x plus 1 to find x1. Next, read across to the line y equals x to map this value back onto the x-axis, as shown here. If we repeat the process, as shown, we can show that the values of xn well, we can see that the values of xn are converging to the root of the equation y equals root x plus 1, which is also the root of f of x. Notice in this diagram that successive iterations get closer to a root in the same direction. The resulting diagram is therefore called a staircase diagram. Let's now take a look at part B. Another iterative formula produced by f of x equals 0 is xn plus 1 equals 1 over xn minus 1. Here's a sketch of the curve y equals 1 over x minus 1. And superimposed upon that is the curve y equals x, or the line y equals x. Again, we're going to try and find the intersection point of the two graphs. Let's begin with x naught equals minus 2. We read up, or down in this case, from x naught on the vertical axis to the curve y equals 1 over x minus 1 to find x1. Next, read across to the line y equals x to map this value back onto the x-axis. We now repeat the process as shown, and we can see that the values of xn are converging to the root of the equation y equals 1 over x minus 1, which is also the root of f of x. As you can see from the diagram, successive iterations alternate below and above the root, and this results in a diagram which is called a cobweb diagram. Now let's take a look at part C. Another iterative formula produced by f of x equals 0 is xn plus 1 equals xn squared minus 1. Here's a sketch of the curve y equals x squared minus 1. And superimposed upon that is y equals x. Again, we're going to try and find the intersection point of these two curves. Let's begin with x naught equals minus 2. We read across, or read up from x0 on the vertical axis to the curve y equals x squared minus 1 to find x1. Next, read across to the line y equals x to map this value back onto the x-axis, as shown here. However, this time, notice that repeating the process shows the values of xn diverging from the root of the equation, as shown here. So successive iterations diverge away from the root. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We have a function f of x equals x squared minus 6x plus 2. We are required to show that the function f of x equals 0 can be written as x equals 6 minus 2 over x for x not equal to 0. So let's solve this. Now f of x equals 0 implies x squared minus 6x plus 2 equals 0. And rearranging this gives us x squared equals 6x minus 2. And then dividing through by x gives us that x equals 6x minus 2 all over x. And tidying up gives us x equals 6 minus 2 over x. Now let's take a look at part B. Again, we have that f of x equals x squared minus 6x plus 2. Now f of x has a root alpha in the interval 5 less than x less than 6. We are required to use the iterative formula xn plus 1 equals 6 minus 2 over xn with x naught equals 5 to find the values of x1, x2 and x3. So let's solve this. Using the iterative formula as shown and substituting n equals 1 into this formula, we obtain that x1 equals 6 minus 2 over x naught. And so if we plug in x naught equals 5 into this equation, we obtain that x1 equals 6 minus 2 over 5 equals 5.6. Similarly for x2, if we plug in n equals 1 into the iterative formula, we obtain x2 equals 6 minus 2 over x1. And plugging in x1 equals 5.6 gives us that x2 equals 6 minus 2 over 5.6 equals 5.642857, and so on. Similarly, x3 equals 6 minus 2 over x2. Here we've plugged in n equals 2 in the iterative formula. And then plugging in the value of x2 as shown gives us that x3 equals 5.64557, and so on. Notice that each iteration gets closer to a root, so the sequence x0, x1, x2, x3, and so on is convergent. This brings us to the end of this session. If you have understood its contents, you should be able to use iteration to find approximations to the solutions of equations of the form f of x equals 0. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.